So we've got our next unit on organics that will start this week and finish off at the start of next term. So alkanes. I want to state the definition of the homologous series, referring to alkanes, state the general formula of the alkanes, name and draw the first 5 members, and name and draw branched alkanes with up to 5 carbon atoms. So, homologous. Homo means the same, right? So Homo sapiens refer to like intelligent humans. We are of the same. Logous sort of means like location, right? Or homologous. Homologous or homologous. Family of hydrocarbons. So what does it mean to be in a family? You're all part of a family. I'm part of a family. What does that mean? What does members of a family have in common? They're related in some way. Yeah? It's different, but you're related, right? So a family of hydrocarbons have similar and physical chemical properties, and each subsequent member differs by a CH2, right? Within your family, you differ by slight ages if you've got older brothers and sisters, right? So if you want to think about that from an analogy, you've got a various amount of time difference between you and your brothers and sisters, right? Between different members of a family of hydrocarbons have a CH2 or several CH2 links up. Alkanes, focusing on the A, is a family of what's called saturated hydrocarbons. What do you know of the word saturated? When you think about saturated, what do you think of? What do you visualize? Fat? Yeah? What else? Hydrated. Something to do with water. Yeah? Go out in the rain, you get saturated. What does that mean? What does that look like? You're full, completely full of water, right? So a saturated hydrocarbon is one in which has the maximum number, is saturated with the maximum number of hydrogens possible. Yeah? So all the possible bonds are made up of carbon to hydrogen. Any questions on that? Oops, too far. The general formula for alkanes is the formula CN H2N plus 2, where N is a whole number, right? So let's have a think. If N is equal to 1 carbon, how many hydrogens do I have? 2 times 1 is 2. Add 2, 4. So the formula for an alkane with 1 carbon is CH4. Make sense? What if I've got 2 carbons? 2 times 2 is 4. Add 2, 6. So we get C2H6 is the second member of the alkane family. And we'll talk about their names and stuff as well. What if I had 10 as my number of carbons? How many hydrogens would I have? 2 times 10 is 20. Add 2, 22. Fantastic. So that would be the 10th member of the alkane family. Yeah? Excellent. The first one is called methane. Meth means 1 in chemistry. Meth, yeah. Right, so meth refers to 1 carbon. So if we want to think of the meaning, meth means 1, ane means saturated, all single carbon-to-carbon bonds. Put the 2 together, it's all single bonds and with 1 carbon. And we got the structural formula there, right? Carbon has 4 valence electrons, hydrogen wants 1, it has 4 single bonds and a tetrahedral structure. Number 2, ethane. Eth means 2 in chemistry. Eth refers to 2. there was what was called the ether, which is where the name sort of comes from. Ether was once considered the thing of which connects all matter within the universe. We now know that not to be true, that we have most of the space is empty, it's a vacuum, there's no particles at all. But some of the names remain. So, formula C2H6, semi-structure, right? Semi-structure doesn't show every bond. Instead, right, we condense it by removing all the actual structural lines or the dots and then group them together with in lots of carbons. So CH3 bonded to CH3. Then we can look at the structural formula of that. So notice around every given carbon we still only have 4 bonds. Hydrogens still only have 1 bond. Yeah? Common mistake might be to draw it something like this. Right? Where I've put in an extra hydrogen or something like that. Right? But from a chemistry standpoint, this doesn't make sense because hydrogen can only have a maximum of 1 bond. This has got 2. Yeah? Third one, prop. Prop is 3. So propane, 3 carbons. Ane, all single bonds. Molecular formula, C3H8. Notice how, remember back to that definition of a homologous series, each subsequent member increases by a CH2. So CH4, add a CH2 gives us C2H6. Propane, we've squeezed in a CH2 in the middle. What do you expect will happen with our next member? Right, we squeeze in another CH2 in here, 4 carbons, yeah? So prop is 3. Butte is 4. Unlike normally we would think of 4 as being like quattro or tetra. Butte comes from the term butyric, or where we get the name butter from. So butyric comes from butyric acid, which is from rancid butter, and it smells like vomit. That's where we get Butte from. Butte is 4. I know, it's great. Awful, awful stuff to work with. If you get an alcohol made of Butte, right, butanol, has the same refractive index. Does anyone know what that is? Right, it's how much light bends through the material. It's got the same refractive index as water. So if you get a glass stirring rod, put it into butanol, it disappears. Really cool. Not cool. You're shaking your head. Right, and now what we might expect 5 carbons to be. Pent, as in pentagon, 5. 5-sided objects. So our first 4 are different to what we normally expect with prefixes. Our next one and subsequent ones follow along with the same as where you may have seen them before in maths. So the 6th member is hex, 7th member is hept, 8th member is oct, non, dec, right? So we've seen those in shapes before, I hope. So again, we're squeezing in another CH2 in between. So there we go. We know what a homologous series is and referring to alkanes. We've named the first 5 members and being able to draw them. Now, we're not expecting you to draw in 3 dimensions. So if we draw this flat, or we call it the linear structure, it's not a linear shape, right? But it's a linear representation whereby we're just linking all the carbons together in a linear fashion. The true shape of this is the shape around each of the carbon centers will be tetrahedral. So I just want to make that distinction really clear. Linear simply means, in this context, linear means we're joining all the carbons together. Versus branched is when we might have a carbon coming off, say, here or here. Bit of an extension. Hex, right? 6, hept, is 7, oct is 8. And we could continue going on, but we don't need to at this level. When you go into VCE or IB chemistry next year, for those of you continuing, right, we'll go up to about C10 with isomers up to, we'll talk about isomers, up to about C8. And that's the next part. Iso means the same. We've seen this before with isotope, right? Isotope is the same element with a different number of neutrons. Isomer is the same formula, right? But a different structure. So we rearrange the bonding. More so, we're rearranging how the carbons join up with other carbons. There's only one way we can do that with methane. I can't, because I've only got one carbon, I can't join it up with any other carbons, if that makes sense. Same thing with ethane. I've only got 2. So there's only one way in which I can rearrange those. Same thing with propane. I can move this around to here or this around to here, but I still have 3 in a line. So there's no isomers for methane, ethane, or propane. So the first alkane compound that can have an isomer is butane. So what I'm doing is, if I take my laser pointer, is I'm taking this group of CH3 and I'm swapping its position with this hydrogen. Right? Does that make sense? I'm swapping this group of CH3 with this hydrogen, and we can see it's gone down here. And the name changes. We can call it isobutane, might be the common name, but this is called the IUPAC. IUPAC is like the governing body of chemistry in the world. It stands for the International Union of Physical and Applied Chemistry. So they come up with the universal laws as to why all the elements on the periodic table have the same symbol across the world. Question? And they have a naming structure, a systematic naming structure that's the same universally. So that if I'm in China or Iceland or Czech Republic, I name a structure, it's going to be the same there as it is here. We have 2 different isomers of pentane because there's different ways in which I can rearrange those groups. I have methylbutane, so this name comes from, it's a butane backbone with a methyl group, right? A single carbon branch coming off that carbon there. Sometimes we'd refer to it as 2-methylbutane. This one here? Here? Yeah. Right. Well, I'll pause it here and I'll show you that on the board from backbone, 4 carbons in a line, and a methyl group, 1 carbon coming off. Dimethyl, di means 2, so I've got 2 methyl groups coming off a propane backbone. So 1, 2, 3 carbons, and then coming off that second carbon, I've got 2 methyl groups. Also wanted to highlight that if I had, instead of the carbon coming off here, and had the carbon coming off this carbon, that too is the same. Remembering it's 3 dimensions, if I have the carbon coming off here, it will be again the same molecule rotated 180 degrees. Yeah? It's like saying the pen leads this direction. If I rotate this 180 degrees, it's still the same pen, just the lid is facing that way. Same thing if I had the group coming off here, right, off the second carbon. Let's match that here. And then if I rotate that around, so it appears to come off the third carbon, but it's still coming off the second.